All right, my friends, let's take a look at what are called inverse functions. And so what these things do, what inverse functions do, is they undo the actions of a function. All right, so let's say they undo the actions of a function f of x. And so to see exactly what I mean by that is, let's look at a particular example. And so if you say there's a function out there that's like f of x equals 3x minus 2, right? So if you look at what the two actions of that function are, right, the first thing that this function does is it multiplies by 3. So we'll say that's one action it takes, is it multiplies by 3. And then it subtracts 2. Well, so if we want to undo that process, right, we have this transformation that's happened. First we multiplied something by 3 and then we subtracted 2. Well, if we wanted to kind of like undo that, you can kind of go backwards with this and just say, well, what would be the, if I had to go back to the beginning, well, the first thing I would do over here, I'm making the inverse function to undo it, is the first thing I would do is add 2, right, and then divide by 3. Right, and that should undo it or be the opposite of what we just did, okay? Divide by 3. Well, so what would that function look like then if we first add 2 and then divide by 3? Well, that function then, f inverse of x, would be to take something and add 2 to it and then divide that whole mess by 3. So allegedly this is the inverse function, all right? And just to get us ready for something we're going to see in a moment, I'm just going to sort of distribute the 1/3. So we'll get like 1/3 x plus 2/3 is our f inverse, right? So what we'll do is let's take a look at this graphically. So this allegedly is the inverse function of this one. So another thing that we could do in thinking about generating an inverse function is, if you go back to this vision of a function as being like there's an input and an output, right? So this is kind of your input, and then your output is over here. So we've been representing that as a graph, right? And so if we do, let's say, make a little chart of input and output for f of x, if we input 0 for x, so 3 times 0 minus 2, you get minus 2, right? If you input 1, you get 3 times 1 is 3, minus 2 is 1. So the function is going here. You can recognize this as a line of slope 3, intercept minus 2. And so likewise, if we put in, that was if we put in a 1. If we put in a x value of 2, 3 times 2, 6 minus 2 makes 4. And so on. So you get this graph with a slope of 3. Going over 3, you would get 7. So we start to kind of build up this line of slope 3 that is f of x. Right, so there's our line, right? So realize that your input, let's say of 2, generated an output of 4. Okay. What we want to do is reverse this for the inverse function. What we want to do is say, what if I input 4, I want to make something that's going to give me an output of 2, right? So what you're doing is you're kind of reversing it. You're saying, if I use this as my input, what output would come out of it? And so since you're reversing the input and the output, with a normal function, this is the input, this is your output. If we're reversing that though, if we're saying this is your input and this is your output, that's basically like reversing these axes, or just kind of swiveling this thing around, right? And so for instance, with this function as graphed, 3x minus 2, if we just write down some of the ordered pairs that we made, so for instance, with an input of 3, it made an output of 7. With an input of 2, it made an output of 4, right? Well, let's do the reverse of that. Let's suppose whatever was on the output, we use that as the input instead. So again, that's kind of like reversing these things. So what I'm going to do is graph in red here. We're going to switch these around so that that is sort of our x-axis, and this is our y-axis. And so what we can do is say, well, then in this case, with an input of 4, we should get an output of 2. Okay, so with an input of 4, we get an output of 2, and that would put us here. With an input of 7, we get an output of 3. So you notice what we're getting here, if you just kind of connect these dots, you see what's being built up, is you can see we're going to get this line with a shallower slope. In fact, it's going to have a slope of 1/3, right? And so in fact, now we can see if we go back here, go back 3 units, you'll go down 1. So we'll cross this point 1, 1 here. And what you can see is that we're going to end up crossing the axis right here if we plot this back. And so you can see here we've generated this line that looks like this. That in fact is the graph of, let's say, 1/3 x plus 2/3. So you can see what's really happened here since we've kind of switched the x and y axes. You can imagine taking this line at the black graph and swiveling it to make the red graph. And so really what you've done is you've flip-flopped this graph over this 45-degree line over y equals x. You've simply flipped it around this line, mapped it down like that. So that's a graphical way to see what the inverse, taking the inverse of a function would do. So you're simply switching the y and the x, you're switching the input for the output and finding how to undo a function, right? Final way to kind of check that this worked, right? I know this is an easy example, but of course this worked, but just to see that this really is the inverse. Another thing you can do is put the original function in here and just kind of check algebraically that this undoes the original function. So for example, if you put in f of x for x, so if we say f inverse of f of x, right? This is supposed to undo the function f of x. Well, let's see if it actually does that. So let's put f of x in here for x. So we're going to say it's 1/3 of f of x plus 2/3. And let's just see what happens when we do that. The marker's getting a little bad. So let's plug that in. So that's equals 1/3. Now f of x itself is 3x minus 2. Right. So that's putting 3x minus 2 in for f of x. Then we have to add 2/3. Now, if you notice what happens here, we get 1/3 of 3x. Well, that's just going to be x. So there's our leading term as x. Now, if you look what happens here, we're going to get minus 2/3 and then plus 2/3. Oh, so that's going to be plus 0. Oh, so we're back to getting x. So we find out that this thing did work. It really is the inverse function. So hopefully that gives you a little start on what is meant by an inverse function. Just think of undoing the actions of a function.